So Zoltan noticed that when we do updates on content items, when one deletes a document, all the index tables corresponding to the document type get a delete query. And apparently this delete query is actually a single delete query. So I had some code before that was trying to batch them, but didn't did a benchmark and realized that nope, the code is there, but it doesn't work because Dapper is used wrong. So he found how the thing I was typing to use Dapper was not working because there is a weird behavior inside that. If it's not the correct collection, then it's not batching stuff. And even though it's not actually batching, it's just sending multiple requests. And this is what you get on actual websites. So what's the difference between the two lists? Locally and SQL Server. So if you run locally using SQL Server and you have 1,000 what indexes, okay, 1,000 indexes, it takes 1 second. So you might not notice that it's slow. It's slow, but it looks like maybe because I have too many indexes. But when you use SQL Server on Azure SQL Server, then 28 seconds. So you start noticing it even after 100 indices. Apparently, we have around less than 20, I'd say, today on Orchard Core, but you can quickly arrive to 100. I don't think you'll get more than 100 because if you have 100 indexes, you have other issues with your website and it's a different scale, but still 2 seconds per page is not acceptable. So the issue was, so you could definitely see the issue about the deletes and a delete of an index is the fact that with YesSql, when you update a document, it needs to update all indexes. So it will rebuild them. And an index can return multiple records. Like if I'm indexing the name of someone, I might want to index the first name, the last name, the middle name, and have 3 records, 1 per name. So what it does is it builds the 3 new records in memory, and it will send a query to delete any record that were associated to the document, and then sends 3 inserts for the new records. Okay, so you have like 1 for the delete and 3 for the inserts. But it sends a delete even for indexes that didn't return anything, because the fact that you didn't return anything might mean that there is nothing anymore associated. So you need to delete and then send nothing. So this way we get a delete per index. That's not optimal, but that's how YesSql works. And that's optimal for reads and not writes. The goal is to make reads faster than writes. Still, we should not have to send 1 independent query to do the deletes per index. So that's what this issue is about. And I managed to fix it. I got some pressure, and under pressure, I behave better. So pull request, I will look at the close because then you can see the before and the after. We showed that. SQL reimplement filters. What is that? Reimplement filters. I'm confused. What is that? What did I do? Jesus.
That was your when syntax.
The when. Yeah, the message is totally. Oh, thank you. Yeah. Something we can talk about also later. But this one, this is the PR. So. Okay.
That's the other PR. Down a bit. Re-implement batching.
That's better. I like the title. This is what it needs. Because I did implement batching once, like last summer, but this is what I didn't realize that, no, the way I'm doing SQL Dapper is wrong. It's not doing batching. Well, I did some batching, but not for everything. And the thing that it batched didn't matter. The thing that mattered was not batched. So here, I did some changes, didn't check that, and it was better. So before batching, with 1,000 on SQL Azure, we were at 27. After batching, 15. Okay, that's better. And locally, with
and I will point out that my internet connection was running really slowly that day, and I had a lot of trouble getting to Azure. So I think it's probably faster than that. But
even even with 1 index, it was 3 seconds. So that was an issue.
Yeah. So Big internet problems that day.
Okay.
So
we
not reliable, but better.
But locally, we can see that even with 1,000, we get, so it's not no exponential, like, well, it doesn't look like before. So one index 0.22, 100 0.09. So yeah, that's super stable here, even with 1,000, compared to before, like 1.2 seconds, 3 times faster here, even with 1,000. So faster every time. And this was the first set of changes where I could update something. And how it looks like is, I thought I had pasted it. Yes. So I have multiple tries here. I did local setup with a migrate feed and it works fine. When I create a blog post, here are the only batch that is sent. Okay. So if I create a blog post in Orchard, after the change, there is a single communication which is done with database that contains everything here. So create the document, create the content item index, update the content item index with the document ID. So it's done in 2 steps because there are some cases that it can't be done in 1 step, some reduce index. Again, an index and again index. So you see content item, contained, and author part index. So that's the 3 indexes to update. When we create a blog post, when we update a blog post, then the deletes derive. When we create a blog post, that's fine. There is nothing to delete because there was nothing before. So it knows there is no delete to send. But when we update, it says, okay, delete all the indexes. And all these indexes here, it's actually wrong because there is no layer metadata index on the blog post. But today the code is too dumb. It just says, well, there is a content item and there is an index for these content items, for all the content items. It's called the layer metadata index. So I'm not sure if this one might have some indexes for layer metadata. So it says send a delete just in case. So that's dumb, but the other ones are fine. And you can see here for each index, we have a delete. And it used to be a single query, communication query with database. Now there is a single communication that contains everything. It used to be like 20 queries. Okay, now it's a single one with n statements. So much more powerful. And after that, I was able, you see, so I think I didn't notice that, maybe that's me or both of us, notice that there is an insert and update, and the update is could just be merged into the insert because this value is already known from previous. So we could just update that. So I did some more complex ifs in the code to optimize the optimizable ways. And after that, again, now we have that list of, so it's still a single one, but instead of this amount, we divide by 2 this part. So instead of having insert update for each index, now we have just insert. And one case, an update, but it's different. It's just updating the local ID. We still have all the deletes, and some of them are useless, but these are quick. So we have just that now when we update a blog post, a single one. And then there is the other PR that I was confused what it was, and it shows what's happening after. So with the other PR, we are able to teach the index when not to send deletes. Like there will never be any index created for this document, so don't send deletes. And after that, we can see that there is no more the layer and no more the alias because the blog post doesn't have an alias. Okay, so these 2 can be omitted and it finds it. And this is by having a new property, a new method on the index provider to explain when to not use the index provider. So it will not even go to the map thing. In this case, we say, if you don't have the alias part, don't try to go in the alias index. Okay, so that's what it does. But it's not yet enabled on OC because there are some issues. Sometimes we don't know that we can't have that. For alias, it's easy. For taxonomy, it's harder. So we'll see. But yeah, that's the big change. So it will make things faster. On writes, on reads, it's exactly the same thing. There is no change. I don't think there is anything to do on reads, but there are some features that could be implemented, like being able to send 2 queries at the same time and then read the results serially. It's not usual that we do that, but that could be supported in case people want to do that to optimize things. But right now it's it's easy enough. So that's how it looks like. So that's a big change in YesSql. And with a big change come bugs, new bugs. And Sipke, who is using YesSql in ELSA, has found 2 bugs. One has been fixed and another one has yet to be fixed. The issue being that now I used to use Dapper to send. I used to let Dapper create some queries like update and any sets. And now I have to do them by myself to build the queries because they have to be batched. I need to get the statement. I can't let Dapper create the statement for me. I need the statement. So I already had it for some cases, but I need now to compute with also the values. And we are finding issues there, mapping between .NET objects and SQL. But this will be fixed soon. It already works in Orchard Core, just specific, very specific usages like using an enum directly in the index instead of mapping it to an integer or a string. Or using datetime offset, which we don't do in Orchard Core because we know it's useless, it's bad. We can just use a datetime UTC and a different time zone field. So that's it for YesSql. No questions. It's fast. Oh, something else. It's fast. Antoine suggested to have some benchmarks. That's good. But it's funny because before you suggested that, Antoine, I did run a benchmark like I used to sometimes locally on Orchard. So I run a load on the blog post and even on the about page, and super disappointing. It looks like it's slower than it used to be a year ago. So I have to dig into that. But even without, it's not even related to database because it was just reads, but something is, so it's still super fast. You can feel it when you use Orchard, but it's at least twice as slow as it used to be last year on my machine. And at first I used my new laptop and I'm like, okay, maybe my laptop is slower than my desktop, and I tested it on the desktop, but I have the same result. So I think something weird went in. We have to check at some point. So we'll look into that later.